All right, hey everyone, and welcome back to Organic Chemistry on YouTube. Today we're going to be talking about the epoxidation of alkenes, and we'll be doing this reaction with what's known as a peroxy acid. So first of all, these reactions are concerted. They involve a syn addition of an oxygen atom to an alkene. This forms a cyclic ether, which is somewhat strained and really important as an intermediate for future reactions that we'll cover. And finally, MCPBA is the most commonly used reagent for this reaction. So let's first introduce what MCPBA is. So this is metachloroperoxybenzoic acid. And you'll see that this molecule is related to benzoic acid, the parent molecule. And suppose you have the addition of an alkene plus MCPBA to afford then this epoxide. MCPBA and a solvent that'll dissolve your reactant and reagents. So this is the mechanism. The carbonyl lone pair, shown here, deprotonating this relatively acidic peroxy acid. The oxygen-hydrogen bond migrates over to the 2 position of the alkene, while the alkene then attacks the oxygen and breaks the oxygen-oxygen bond and kicks that electron back, those 2 electrons back onto the acid, leading to the peroxide plus, now we just have the metachlorobenzoic acid. So like some of the reactions we've covered already, this reaction is stereospecific. It has a concerted mechanism. And the epoxide can react with nucleophiles. Okay, and finally, just some questions you might want to ask in office hour. 1, can the reaction be accelerated with other substituents? So instead of chloro, could you put a cyano group there or a nitro group? 2, are there examples of competing reaction mechanisms? And 3, what kind of nucleophiles actually react with epoxides? Are they strong nucleophiles, weak nucleophiles? And are there a certain type that can be used with this reaction? So with that, thanks very much for tuning in. This has been Organic Chemistry in 5 minutes or less.